Welcome to another episode of Poorly Explained. In this series, I take a complicated topic that I don't understand completely. I simplify it down for myself as much as possible so I can get my head around it, and I try to relay that to you. This video is not so you become an expert at something, but just so you could sound a little bit smarter when you're having drinks with your buddies. So what we're talking about today is difference between CPU and GPU and why we may want to use GPU for certain computer tasks. One of the things we hear a lot about is generative AI. And when people talk about generative AI, they talk about what kind of crazy video cards they installed in their systems or companies buy in order to be able to process data for that generative AI to crunch through the data. And the question that always comes up is like, why GPUs? What's special about GPUs versus CPUs? Why do we use one instead of the other? Is one faster than the other? And that's a complicated question, which we're answering today. First, let's start with the CPU. The way CPU works is it processes data sequentially. So think of like a list or stream of instructions that go into a CPU. Instructions might be take this data from memory, store it here. Now take the data that you stored, add 5 to it. Now do something else, then save it somewhere else. So there is like a stream of instructions that come into a CPU. Or we can think of it as like a to-do list. And the CPU just goes 1, 2, 3, and it just knocks out all those instructions one at a time. To make this process a little bit more efficient, we can actually give CPU couple of streams, right? We can give it 2 streams of instructions. So this way, if instructions in one stream says get data from memory and it takes a while to get that data, well, the CPU could switch to a different list and work on that for a little bit until data comes back, and then it can switch back to the first one. And so we call that multi-threading. That's why you see double the number of CPUs in your task manager than your computer actually have, because each core of a CPU gets 2 data streams, so 2 to-do lists that it is working on at the same time. Now, GPU works very differently from CPU. Instead of having stream of instructions, you have one piece of instructions and lots of pieces of data. So let's imagine you have Excel and it goes, hundreds of columns and hundreds of rows, right? You have like a few thousand cells in your Excel of just numbers, right? And you want to perform some kind of calculation. You want to multiply each cell by 5. So if you tell CPU to do it, it's going to go to the first cell, multiply by 5, save it, go to the next one, multiply by 5, next, and it's going to go across multiplying each cell. Now, when we do it, it happens very quickly, so it almost happens instantaneously. But as far as computer concerned, it just goes across and just multiplies all the cells by whatever number you asked. Now, the way GPU approaches this problem is different. It is able to multiply every cell in Excel by whatever number you asked, but do them all at the same time. So while CPU does 1, 2, 3, 4, 5, the GPU would multiply them all in the time it takes CPU to do one cell. So basically, all the numbers in Excel would just be flipped to the new value instantaneously, not one at a time. But a very important distinction here is all the cells receive same command. So CPU, you can say multiply this cell by 5, this by 10, this divide by 3. When you do the same thing in GPU, you have one command, but multiple sets of data. But it is one command, one instruction that is applied to all the cells at the same time. That's how it's able to calculate all cells at the same time. You cannot do different logic per cell. Another downside to GPU is that it takes time to load data into all these cells. And then once you do the calculation, you have to read them all back out. So is there one way that's better? Can you say CPU is faster than GPU? No, they are just different tools for different problems. And you have to figure out what is it that you're doing. Do you need to use CPU for a particular problem or the GPU? Knowing how they work, programmers are able to figure out what works better in what situation and use the appropriate hardware. So that is my explanation of CPU versus GPU. I hope it helps you to understand, and I hope it helps you to use Microsoft Excel with thousands of cells filled in as an analogy so you could visualize how both systems work. Thank you for checking out this video. Don't forget to follow on LinkedIn, subscribe on YouTube, and I will see you in another video.